Hey guys, Ms. Rivera here, and today we are going to be looking at polynomials or the graphs of polynomial functions. So you will need to use a graphing calculator, or you can use Desmos. So Desmos.com has an online graphing calculator. It's pretty good. We're going to be using Desmos today for our video. So when you're going through this, you'll notice that there are 8 different questions. So here's 1, here's 2, here's 3, 4, 5, 6, 7, and 8. I want you to pick 4 out of the 8 of them. And 4 of the ones that you want, 4 out of the 8 of the questions, and complete those. All right. Any of the ones that you want. We're going to do number 1 together, so you guys will actually be submitting 5 different questions. But just pick 4 other ones, so it's your choice. So you don't have to do the entire 8, but you will do 4 out of the 8 questions with number 1 already completed together. So let's look at this. So it says, if p of x, let me just put my pen on here and draw it out. Okay, so if p of x is equal to 3x minus 3x squared minus x plus 3, and p evaluated at 3 is equal to 0, what is a factor of p of x? All right, it's that word factor. We know some things here, right? In the last lesson, we looked at, or in the last 2 lessons, we looked at the factor theorem and the remainder theorem. And the factor theorem said, when we divided the polynomials, if the remainder was 0, then whatever we were dividing by is our factor. And the remainder theorem says, well, if we evaluate, right, or if we plug in this value into our equation, bam, bam, if we plug it everywhere we see an x, right, so we plug in a 3 everywhere we see an x, and if we get 0, then whatever we're plugging in is a factor. This, when we put it in factor form, x minus 3 is actually a factor of the polynomial. And so if we look at the graph of this, let's think about the graph of this polynomial function. What will it look like without even putting it in a graphing calculator? Well, if we look here, the degree of our function is a degree 3, so it's cubic. And then if we look in here, our leading coefficient is 1. It's a positive 1. So it's a positive cubic function. So it is going to be rising. So let's look, it'll look something like, it's starting from the bottom, crosses the x-axis, crosses it again somewhere, and then goes up. Now, I don't know necessarily exactly where it is going to be crossing, what numbers these might be. And we're going to look more into that when we get into the Desmos. But more or less, this is the shape of our graph. There are 3 real zeros here. Now, those are our maximum number of zeros. We can have 1, we can have 2, but because this is cubic, the max numbers we can have is 3. And so if you see, right, everywhere that it crosses the x-axis, that's actually when our y is 0, our function is actually 0, right? So it relates to that. And so what this says is when x is 3, somewhere around here, when x is 3, our graph of our function is going to cross the x-axis at that point. So that actually means that x minus 3 is in fact a factor of this polynomial. Now we still have 2 more that we might possibly have. We just got to look at the graph. So let's open up Desmos. I'm going to slide this over so that I can get Desmos on here. Let me get it. Desmos. All right. And I'm going to put our other paper on the side. Okay, and let's evaluate, or let's look at the graph of this function. So I put this on the side over here. All right, so we're going to plug in x cubed minus 3x squared minus x plus 3. All right, so this is what our polynomial function looks like. If I can expand this a little bit so that you can see. All right, we basically, it looks like what we drew it is rising. It does cross at 3 points. And in here it says, look, when x is -1, your function is equal to 0. If you plug in a 1 to it, it is also equal to 0. And if you plug in that +3, just like we did in our example, then it is also equal to 0. So those are our three real zeros, but we need to put them in factor form. So if you remember that for factor form, we have x equals to 3, which is the one we already did. We have x equals to 3. Let me change the color of my pen. Is it still recording? There we go. Let me change the color of my pen. Okay, I'm going to change it to purple. We'll do blue. We'll do blue. All right. And now I have x equals to 3. I have x equal to 1 and x equal to -1. So x equals -1 and x equals 1. And what I want to do with that is I'm actually want to set them, I want to make it so that everything is on the left side and only zeros on the right. So how do I move the 3 over? Well, I got to subtract 3 to it. So for this one, this just becomes x minus 3 equals 0, right? When I subtract 3 from 3, I get 0. On this one, this is going to become x plus 1 equals 0. And I wish I had a better mouse or a pen. This would go so much better, but here we are. All right. And then lastly, this 1, when I move it to the other side, I have to subtract 1 from both sides. So it's going to be x minus, oh, that's a horrible x. All right, x minus 1 equals 0. So these are your factors. Factors. And so I did have a mouse and it's disappeared. All right, so x minus 1, x plus 1, and x minus 3. X plus 1 is a factor, and so is x minus 1. Those are our 3 factors. And you see how easy that was? It was so much easier just to do it on the graphing calculator than it is to be dividing polynomials or to evaluate the different polynomials different ways, right? To try to factor it out. Just go on to the graphing calculator, look at the x-axis, and just remember this part. You have to put it in factor form. Otherwise, you're going to get incorrect answers. Instead of -3, maybe you would have put +3. So you want to be careful with that. You want to make sure it's in factor form. Okay, and then if we continue looking on here, actually, if you have your, I don't know if any of you took your folder, but some of these we've done before. So if you recall that, or you have your notebook, or you have your folder, then some of these are already done for you. Okay, and see, oh, I'm sorry. So for here, right, you want to figure out which function is going to represent what's going on here. And I know specifically we did this one, and many of you told me what the answer would have been. So hopefully you can recall that one. And you would just want to look at what the question describes. So we go to the next one. All right, what is the remainder when you divide this polynomial out? Remember, you can go ahead and look at the graph of the graph of the function when x is equal to that +1 and see, hey, where is the function? Is it 0? Is it on the x-axis? Or maybe it's not, and it's on when you plug in the 1. When x is 1, when you plug it in, your y might not be at 0. Maybe it's at 30. Maybe it's at 24. Maybe it's at 12. Or it's at 0. All right? So you want to see what that is. So you can look at the graphing calculator, or you can just do synthetic division. What's your remainder? Or you can plug in the 1 into the equation. Many different ways to do that problem. All right? Here, right, it says when you put this into here, so you're going to plug this in here, right? What do you get? Determine the zeros when n is equal to 2. Explain what the values of n affects the zeros. Support your answers with an algebraic statement, right? So you're going to change. So for here, f of x, it says it is actually equal to g of n So 1 divided by n minus 4, x squared plus 2, 1 divided by 2n minus 4, x, and then it says also put in an, wherever you see an n in the g of n, put in a 2. All right, so maybe it's easier when you plug it in, put in a 2 there, and then see, well, 1 divided by 2 times 2 is just 1. So this really is 1 minus 4. So everywhere you see g of n, well, 1 minus 4 is just 3. 1 minus 4 is equal to 3. So g of n is actually 3. So this says 3x squared, 3x squared plus 2 times 3. We know what 2 times 3 is, right, guys? 2 times 3, x. Oh, so if I go one more time, well, this is actually just 3x squared plus 6x. And now I know how to evaluate this either on the calculator and determine the real zeros of it. So I would plug this into Desmos, look for the zeros, and it says it. Determine the zeros here. Determine the zeros. Once you get what is x equal to when y is 0 or when it's on the x-axis. And now explain how different values of n will affect your zeros. Okay? Number 10, for an unknown polynomial function, p of x, when you evaluate it at 4, or p of 4 plus 2, it equals 2. So which binomial has to be a factor for this to be true, right? So when p is of 4 plus 2 is equal to 2, what does that mean? Well, if I subtract 2 from this side, and I subtract 2 from this side, that means that p of 4 is equal to 0. From here, recall in our number 1, what are the next steps? How can we determine which one is a factor, right? We know right off the bat there are 2 that we can eliminate because they don't have a 4 in it. But now we're left with C or D. You pick which one's the correct answer. And then the next one, which statements are true? Select all. One is a root. One real zero is -4. One real zero is 29. You figure that out. If f of x is divided by g of x, the remainder is 29. You can divide them synthetically or however, and then figure out what the remainder is. G of x is a factor of f of x, or g of x is not a factor. So one of these definitely is going to be true. All right, let's continue. Look, more real zeros. There's some division going on here. So I believe that's it. Yep, that's it. Equivalent, right? We can put this in the calculator. We can put these in the calculator and see which one gives us the same graph. All right, on Desmos. All right, I think that's all. So if you have any questions, feel free to reach out to me if you don't understand the assignment, or maybe you need some extra help one-on-one time, however it is. We can work together on Teams, however you need it, or want to do a small group, we can, so we can work together on the assignment. All right, again, see you soon. Bye.